Okay, so we are going to do the other two examples for stoichiometry that are on your notes, and then I'm also going to post a third example video that is not done by me, but it's done by somebody else, just so you can see somebody else's explanation and a few other examples for these. So if you go to example number 2 on your note sheet, it says how many grams of carbon dioxide are formed when burning 5.6 grams of methanol. I'm going to change the carbon dioxide to be water just so that you guys have a different example than one that we did in class. So we are going to start with the 5.6 grams of methanol. So that goes on the upper left, or sorry, upper left of your problem. Methanol is the CH3OH, so that goes over here. Our goal is how many grams of water, so that's what's going to go on the upper right. H2O is our water. Now, if you go back to your stoichiometry notes, where we talked about how many steps we'll need, if we are going from grams of one thing to grams of something else, that is an automatic 3-step problem. So we know that we're going to have 3 steps in this conversion problem. We're going to start by taking our units from our upper left, grams of methanol, and we're going to place them down below here. So grams of CH3OH. In order to find our mass of any chemical, we need to look at the periodic table. So we're going to look up carbon, oxygen, and hydrogen all separately. Carbon, we only have 1 times the mass, which is 12.01. So that carries through 12.011. Oxygen, again, we only have 1 of those times a mass of 15.999. So that one also carries through and does not change. Hydrogen, you have to be careful with this one because the hydrogen is split in the formula. You have 3 hydrogens here and 1 here. So we're going to have 4 hydrogens all together times 1.008. Gives you 4.032, which means that our entire mass of the methanol totals up to be 32.043. Oops, 042. So we're going to put that up here in our problem in front of grams of methanol that we got from the periodic table. If you take a look at your roadmap, your mole roadmap, on the opposite side of your molar mass is always 1 mole of that same thing. So your label does not change. So it'd be 1 mole of CH3OH. With that, our grams of methanol cancel out and we're left with moles of methanol. Now that's not what we want, so we need to cancel out our moles of methanol, so moles of CH3OH. And if we don't know what we're going to go to, I always tell you put your goal up on the top. So we're going to put grams of H2O. Now you need to ask yourself, can I go between those 2 units? I'm changing moles to grams and I'm also changing methanol to water. I can't change 2 things at one time, so I need to, instead of going to grams, I'm going to change that and make it so that I go to moles of water. With that, I have a mole to mole ratio here. So I have moles on the top of my fraction and moles on the bottom of my fraction. That means that I need to find my molar mass, and I get that from my balanced equation. So it's going to be different every time you have moles on the top and the bottom of your fraction. The number in front of water is a 4, so the number in front of water in my problem should be a 4. The number in front of methanol is a 2, so the number in front of methanol in my problem should also be a 2. If I continue on, I can see that my moles of methanol have now canceled and I'm left with moles of water. I don't want moles of water, so I'm going to cancel that out. I'm really, really close to my goal. So I need to get into my goal, which is grams of water. I can look at this and say, to myself, or ask myself the question, can I go between grams of water and moles of water? That's my molar mass, so I'm changing only my unit. My label's staying the same there. In order to find my mass, or my grams of my water, I need to look at the periodic table. I have hydrogen and I have oxygen. I have 2 hydrogens times a mass of 1.008, and so that should give me 2.016. And then oxygen has, I have 1 of those times the mass of 15.999, so that also carries through. When I add both of those together, I end up with a mass of 18.015, and that is what goes in front of my mass of water up here in my problem. I always have 1 mole on the other side of grams, so I'm going to put that down below. My moles of water cancel out, and I'm left with grams of water. When I finish my problem, I need to multiply through everything on the top, and I divide everything on the bottom. With that, when I do that and I solve my problem, I get 6.2969. Now that's way too many digits. I only had 2 digits in my answer, or in my given from my problem. So I need only 2 digits in my answer. To round this to 2 digits, I'm going to end up, oops, that's not where I round. I end up rounding here right after the 2, so that 9 makes the 2 become a 3, so I end up with 6.3 grams of water. And again, box in your final answer because that gets messy, so I know where your actual answer is. If you skip example 3, that's on a previous video, and you go to example 4, example 4 says how many atoms of calcium are in 7 moles of calcium carbonate. Now this, I'm going to modify it so that it actually matches what it says on your note sheet. Instead of atoms here, this should say grams to match your note sheet. So with that saying grams, then I can go ahead and I can start my problem. So I have my given goes in the upper left. I have 7 moles of calcium carbonate. So I'm going to write 7 moles of CaCO3. Now I want to get to grams of calcium. So that goes on the right hand side. So I'm going to have grams of just calcium, not calcium carbonate, just calcium. Now I know I want moles of calcium carbonate to cancel, so that needs to be my starting point here. Moles of calcium carbonate are going to cancel by being put on the bottom. And if I don't know what I want to get into, put my goal on the top. So that's grams of calcium. Now, if I do not have, or if I look at this and I say, okay, I'm changing moles to grams and calcium carbonate to calcium, it's changing too many things at once. So I'm going to modify this to say I'm going to go to moles of calcium instead of grams of calcium. If I look at this, I have a mole to mole ratio. Normally I get that from my coefficients in my equations, but if I don't have an equation, then I need to look at my formula and get it from my subscripts. So if I look here, I only have 1 calcium in every 1 calcium carbonate, so my ratio is a 1-to-1 ratio. It's not always going to be a 1-to-1 ratio, but for this case it is. With that, my moles of calcium carbonate cancels, and I'm left with moles of calcium. Now, that's not exactly what I want. I want grams of calcium, so I need to cancel out the moles of calcium by putting it on the bottom and getting into grams of calcium on the top. Now, grams, remember, mass comes from the periodic table. Grams over mole is our molar mass. So the mass of calcium from the periodic table is 40.078. So that needs to go where the grams are located, and 1 mole is always on the opposite side of grams. With that, mole of calcium cancels out. I'm left with grams of calcium, which is my goal. So then I can go further and multiply across the top, divide across the bottom. And when I do that, I end up with 280.546 I'm going to round that just a little bit. I end up with, I started with only one digit, so if I wanted to be technical to end with only one digit, it would be 300 grams. If you guys rounded to the nearest whole number and I saw that you were rounding 281, I would probably accept that too. So both of those numbers are acceptable. You'd box those in and call it good. Hopefully this was able to help you guys out with your stoichiometry problems. Let me know if there's anything else that I could do for you.